Many speakers have touched about different issues here, processes, production, workflows, etc. We have talked about the consumer side, about set-top boxes, metadata solutions, reference levels, etc. But we have not talked about the link in between distribution, and without distribution also following the idea of loudness normalization, this system won't work correctly. And we have Richt van Everdingen here. He is from the Dutch Loudness Committee and consulting a lot in these matters in the Netherlands. And he was also the one who was mainly responsible for writing our distribution guidelines, TechDoc 3344 in P-Loud. He spent ages and ages writing that. So he is the expert in distribution in our group and will tell you all there is to know about these issues. Richard, please.
Yes, and there's a lot to talk about considering loudness in distribution, loudness normalization distribution. And we have had many meetings in P-Loud, and there were many discussions as well, and also questions like, are we ready yet? Is this all there is? Or do we have to still have to do a lot of work? I even heard the question, is there a future after P-Loud? Yes, there is. But before we can have such an easy life without any problems, I'm afraid that we still have a lot of work to do. Because we have to look at the whole chain. Production, broadcasting, so the playout centers, but also distribution. And not to forget the consumer equipment. So consumer equipment is considered to be part of the distribution chain, and it often is, because a lot of distribution companies specify what the set-top boxes must do and must not do. Sometimes the broadcasters do this. So the whole chain is important, and we may not forget one link in the chain, because we won't achieve our goals. If I look at the documents, here is the main document, R128, with the main levels in it. And this document is referring to tech docs, to practical guidelines. So we have 3341, yeah, there it is, about the measurement devices. And we have 3342, specifically about loudness range. And there is 3343, the practical guidelines for playout centers and production. And 3344, document for distribution. And this is a 90-page document. So apparently there's a lot to tell. If we look at networks at this moment, it's actually a kind of bungee jumping what levels are concerned. So from loud to soft channels, services. And this is not only because of the broadcasters themselves, how they transmit, but there's a lot of things going on further on in the chain. If you look at the goals, the benefit of loudness normalization should be that you could have an easy switch over if you set from one channel to another. Exactly the same like switching from a program to promos and commercials in that respect. You should have the same experience when switching over from one channel to another, and also between systems, because channels, services, broadcasters can transmit with several codecs. We know MPEG stereo in most cases, but also Dolby Digital and high efficiency AAC. That are the most common systems in Europe. Well, if you look at the transmission levels now, this was actually some of the investigations that the Dutch group did. So these are real measurements here. You see that there is a lot of difference what loudness levels are concerned. So these are all loudness levels. And we measured up to 18 dB of difference. So this is almost 4 times as loud for the hearing. So it depends, of course, what kind of switch you make. In most cases it's less than 18 dB, but if you are unlucky and you make the switch from the softest to the loudest, that is really a big gap. And what we like to achieve is actually that we have equal loudness. So this is what we most pleasant if we switch over from one service to another, that the long-term loudness is the same. How can we do that? Because it's a complex situation. Well, if you look at a distribution system, cable head end, for example, you see that there are many sources, many channels are coming in. And also a distribution company is a broadcaster itself, because they have their own playout systems for video demand, for example. There can be ad insertion where the channel is replaced by a local ad. They can have show channels, for example, with sound, of course. So this, rather complex situation in these head ends, giving a lot of trouble for the engineers how to deal with these levels, especially for so many channels. And the equipment itself is, does not help either, because all these equipment have level settings and sometimes even phase settings. And I don't understand really, because I would say put them away in some kind of advanced menu or something, but not on the front, because you can so easily introduce a level problem that can be there for months or even years in your system. Especially with analog systems, this is very difficult, because in digital systems at least you have some reference and steps, but analog systems have really this kind of level settings that are adjustable from any level to any level. So how to deal with this? Well, not with dynamic range processors. I'm sorry for some of the sponsors of this event, but this is not what the EBU members would like to see in the distribution chain, because what is good should be preserved. So fast-acting dynamic range processors is not a solution. It would also be very expensive, by the way. So we are looking for some way to do it more efficiently, cost-effective as well, and it can be done. It can be done by introducing a level alignment for distribution systems, and that is actually included in Tech Talk 3344, the distribution document. It is described very extensively. That's why we need 90 pages. And it is done continuously, so 24/7, but in a smart way. And we need to do that because if, for example, you would apply a measurement for 24 hours a day, just by starting the measurement at a certain moment and stopping 24 hours later, and only taking the integrated measurement, it would be very sensitive for errors and also for abuse. So imagine if you have a station that is transmitting during the night text passage with only background sound. Then this lower average would influence the measurement. If it is just above gating level, then the outcome would be influenced. And so you could abuse that by transmitting during the night on a lower level. And if you would use that data for normalization, then you would not reach your goal, of course, to have equal levels. So how is it done? Well, it is using a measurement in 1 hour blocks. And this is simulating more or less the programs that are transmitted. And after 24 hours, at 3 o'clock in the night, you will have 24 measurements. And there is some analysis of these measurements, and the loudest block measurements are taken out and integrated. And that delivers what we call the loudness of the service. So we call that service loudness. It is one data element, one figure. Also important to mention is that the process during the day is fully static. That means that during the day there is no influence, no dynamic influence at all. So there is a static gain change, yes, but that is applied during the day all the time without interference. So that is actually, one condition, that there is no interference during daily programming. There's something else added, what we propose to do at 3 o'clock in the night, and that is a maximum step size. So when we see that the channel is very loud, and we are, by the way, interested in the long-term loudness only. So for example, a broadcaster that is transmitting 10 LU too loud all the time for months and years. We would like to correct these stations. So what we don't want is an effect for something that goes wrong during a day. For example, a special live transmission that has a louder loudness level. We don't want the effect the next day only because of this one event. And that's why we also included a maximum step size, and that is only limited to half an LU per day. So this increases stability and is actually a second integrator for the measurement part. Well, this can be applied in all systems that we use in Europe. So for MPEG, for Dolby Digital, and also high efficiency AAC. It can be done fully in the digital domain, so without decoding and encoding. And this is important because if we had to decode all the services, that would be very expensive because you have to buy decoders and encoders, especially the encoders are expensive. You would also lose quality with the second pass of encoding. So it is very attractive, it is very efficient to do it in the digital domain fully, and also without degradation. And this can be done. In MPEG it can be done by adaptation of the scale factors, and with AAC and Dolby Digital it can be done by adapting the metadata. And yeah, what we can achieve is something like this. So it looks almost like the graph before with equal loudness levels, but okay, there can be still some differences, but very narrow. So in this case, the surface loudness is very close. But if we go home, we see something like this. What's happening? Because we had equal levels in the head end, but when we go home, we see all kinds of different levels. What's happening? What's happening? I can imagine that you are confused, but this is really happening. For example, if you listen to a TV set, which is applying RF mode, the level is minus 20 LUFS. However, if you listen on a home theater device, the level is minus 31. And you can actually have a jump from minus 20 to minus 31 and vice versa. However, you can also have reproduction on another home theater device with a different level, minus 27. You could listen to a broadcaster that is on target level, so minus 23 LUFS. And it can be anything in between if there is a volume control involved. And this volume control is specifically dangerous in that respect because it often affects only the MPEG sources on a set-top box and not the bit streams. So if you send bit streams to an AV receiver, for example, often only the MPEG sources are influenced by the volume control. So actually the volume control is introducing a loudness problem on most set-top boxes. Confusing? I guess so. Yes, it is, but we can solve these problems. And we do it actually in 3344. Why are these differences there? Well, this is because the reproduction equipment uses different reference levels. For example, a television set uses a reference level of minus 22 LUFS. It was coming from minus 20 actually. If you look at the graph that I displayed in the beginning of this presentation, the levels were very different, but if you average them now, the loudness levels was minus 20. But we are going to minus 23, and this is also the case for analog systems. And this is also the explanation why this level is used in a television set, because there's still an analog tuner inside. So it is for historical reasons based on this loudness level. But this is totally different for a home theater device, like an AV receiver. This one is built around, a Dolby decoder. And this Dolby decoder, applying line mode, uses minus 31 LUFS. So it is built in a different way. Well, the set-top box then needs to take care that the loudness levels using different codecs are aligned. And this can be done, but most set-top boxes do not. So if you feed the signal from the set-top box to the television set, the levels must be minus 23 LUFS, using all systems, Dolby Digital, AAC, MPEG. However, if you supply that signal to an AV receiver, if it is a bit stream, then the internal decoder of the AV receiver takes care of that and uses minus 31, the reference level of the Dolby decoder. But the MPEG levels, if a station is transmitting according to EBU target, the level is minus 23. So actually what the set-top box should do is attenuate the level of the MPEG signal, so decoded into PCM, with 8 dB, from minus 23 to minus 31. And then you align the levels, and then the loudness jump is gone. Unfortunately, there are two families of AV receivers, so minus 31 based, but also minus 27 based, and this adds to the confusion, of course. It's a pity, really, that we have two families, because it makes it more difficult to solve the problems and also to explain to consumers what's happening. This minus 27 is coming from the THX rules, and the manufacturers just need to apply these rules if they want to get the logo on their equipment. You could identify receivers like that by looking at the logo, but that's not the only case, because many manufacturers, for example Marantz and Denon are examples, they made all their equipment like that. So even without the logo, they are all minus 27 based. So this makes it more difficult. If you look at current set-top boxes, I can display the results of a test that the HD Forum in France did last year. And they tested 100 devices, so 100 devices like set-top boxes and IDTVs. IDTVs, by the way, is a TV with built-in set-top box. And the problems are exactly the same. And you see this on this graph. You see how the level would be if you feed this to a minus 31 referenced AV receiver via the SPDIF, for example. Could also be the HDMI output. And what should be, if the set-top box aligns the levels, is that all the dots would be on one line. Well, it's not. In most cases it's not, and then the difference here is 11 dB. So you have an 11 dB jump, and this shows itself also if you switch from one channel to another, from one service to another. If one service is using MPEG and the other one is using Dolby Digital, then you actually face this jump. So what the set-top box should do is align the levels. Now, this is a result for the SPDIF, but especially on HDMI, there's no set-top box at the moment that does proper HDMI alignment. How could this be done? Well, it's not very difficult actually, and it is a proposal in text 3344 to do it this way. It can be done in several ways, it's up to the manufacturers, but actually this is rather an easy question, I think. Because the user is asked which device is connected to the HDMI output, a television set or an AV receiver. That's the question to the user. And that's not very difficult, I guess. It's much more easy than a question like, well, adjust the level for PCM or bitstream. I think that most users don't know what PCM or bitstream is, but this is a setting that you can find in current set-top boxes. So by doing it this way, actually the question to the user is reduced to a very simple one. And there is no level at all in this question. It's only a question, what did you connect to the set-top box? So it can be done like this. And it's all described in the tech doc. Okay, if I summarize what is in 3344, like I said, it contains a way to align levels, incoming levels, for all distribution companies, so including cable operators, DVB-T, DVB-S, etc., IPTV. And if you do that, if you align these incoming levels and the levels that they transmit their own, so VOD, for example, you get equal loudness levels for all services, and not only for digital, but if it is, for example, a cable operator also supplying still analog for several years, then the levels are also prepared for analog. So the document includes analog modulation because we still use that for many years on cable networks, is the expectation. It also includes alignment of analog systems and codecs. So like I said, the popular codecs, MPEG, Dolby Digital Plus, high efficiency ANC, and analog modulation, they are all aligned with examples, graphs, data, etc. In these alignment schemes that are included in TEC 3344, you can even see that the output level of, for example, the SCART interface of a set-top box is exactly the same as the output of the SCART interface of a television set. So you can actually see in the graphs that are included in the document that you will achieve equal loudness levels for these interfaces. It offers a solution for all these interfaces that we have nowadays, the HDMI, the SPF, the SCART, the analog interfaces. So it combines that, the codec alignment and the interface alignment. And it has this, these recommendations for the consumer equipment. So set-top boxes, as it is the most important link in the chain to create a workaround for problems that we see further on in the stream, for example, the AV receivers and the television sets, but also for media players, because the problems in media players are exactly the same as the set-top boxes. So also media players are included in the document. Well, this is actually all included in one document. I mean, it's 90 pages, but it's complete. That's actually the end of the presentation. Any questions?
Thank you, Richard. Yes, any immediate question to distribution? I think a very vital part of our work too is to have the whole signal chain involved, and the distribution guidelines are really a very, very good part of it. So, any immediate questions? Yes, here, please. Is there a microphone here? Just wait a second. Yeah. Thank you.
Just one question. Now that we got this true peak up near the full scale, are there any problems in the distribution chain with that? Have you seen any? Like I've seen that the AC3 encoding has problems when you go too high. Are there any other problems in the chain?
Well, what is included in the recommendation is to have peak limiting at a level of -3 dB true peak for most codec systems. So that is included in the document. If you look at the production level, the maximum level is -1 dB true peak for production. But for the codecs that we use today, we advise to use -3 dB true peak. So this is actually the first limiting stage that is recommended to apply at the end of the broadcast chain of the studio.
But you haven't seen anything in the set-top boxes that makes problems?
Well, of course, if they transmit wrong, in the wrong way, for example, with wrong metadata, you can expect that there will be problems. But if you apply the systems like they are intended, yeah, then it would be no problem. Because, for example, RF mode is also included. That's the special mode of the Dolby Digital decoder to align the levels with analog modulation. So we also included that in 3344. To align the levels with analog modulation and to align the levels for television sets. And this system has its own overload protection system. So yeah, if you transmit in the right way, this overload protection system is included. Does it answer your question? Yeah.
Okay. That's quite a nice system, you know. In all those modulation schemes, FM and in codec systems, etc., it's all based now on the same loudness level as Richard has evaluated. So the only thing that's different is the true peak level, as you just say. So for generic PCM, we recommend -1 because we just can't go way up there. But as Richard just said, codec systems need additional headroom not to introduce more artifacts, because codec systems usually generate true peak levels that are above what goes in. That's very typical, and for AC3 it's about up to 2 dB. That's why we recommend -3 dB true peak. As for coding systems like Dolby Digital or MPEG-1 or high efficiency AAC. But for instance, if you go to really low bitrate MP3, 56 kilobit or so, such an encoder will generate true peaks that are up to 5 dB higher than the input signal. So this is something that is little known also for consumers. They just feed their CDs into the MP3 encoder and they generate distortion all the time. So we have taken all these things into account. So basically all these systems are based on the same loudness level, but have varying true peak levels depending on the system. So in FM, the maximum true peak level, for instance, is -6.7 dB true peak, not to have levels above maximum deviation. So it's all now based on the same loudness level, but with different true peak levels according to the system being used, the modulation system. Yeah, absolutely.
Yeah, it's also important to mention that also FM radio is included. So the alignment and also the automatic alignment of all incoming sources can be applied for FM radio as well, and also for digital radio systems. It could even be used for terrestrial systems, because as Florian mentioned before, there's an MPX power standard from the ITU, and it's used in several countries. And if you look at the energy level of such a system, it's actually very close to what is specified in 3344, with the difference that 3344 uses loudness as a reference, but very close to. So it can be used. There's an opportunity to finally have a loudness-based FM radio system.
That's something we will look at deeply also next year. We will found a separate reflector or a different subgroup in P-Loud dealing with radio, because this is the natural next step. Radio is not left aside. On the contrary, now that TV is going a really good, is very healthy now and going a good route, radio is the next step. And there are very different aspects, as I elaborated in my intro. But this will come as the next step in P-Loud also, to look at the specific issues in radio, definitely.